All right, we're going to go over the last question on page 2 of our assignment. That's question number 365. All right, it says Griffin is riding his bike down the street in Churchville, New York, at a constant speed when a nail gets caught in one of his tires. The height of the nail above the ground in inches can be represented by the trigonometric function right here, where t represents the time in seconds since the nail first became caught in the tire. Okay, so at 0 seconds, a tire has driven over a nail, and a nail has gotten stuck in this tire. So at 0 seconds, the height of the nail should be 0. So this graph should make a bit of sense here. So let's continue. So determine the period of f of t. Okay, so that's the first part. To determine the period of f of t, we can do that by looking at the frequency. And then it says, interpret what the period represents in this context. All right. And then it says on the grid, graph at least one cycle of f of t that includes the y-intercept of the function. All right, so firstly, we can see we have a cosine curve, and we have a midline of 13. So firstly, the midline is 13. The amplitude is negative 13. That means the maximum will be 26, so we'll be going up 13. And the minimum is going to be 0. So notice that this graph has a negative amplitude value, so that means it's going to start at its minimum value, which should be 0 in this case. It will then proceed to its the midline, which is 13. Before I go and continue labeling points, let's label this 0. I need to reach 26, so I need to figure out what to count by. So just to reach 26, 26 is only a multiple of 13 and 2, so I guess I'll count by 2's. So that'd be 2, 4, 6, 8, 10, 12, 14, 16, put a mark here for 16 to not lose my place, 18, 20, 22, 24, and 26. So the midline is at 13, which is here, should be. That's 16, that's 14, 12. Okay, so this is the midline. So if I were to just draw the midline now, obviously if I were using a regular writing surface, I would be using a some sort of a straight edge to try and see it a little bit better. And this is going to take place over a certain period. Now I don't know what the period is yet, so let's figure out what the period is. So it's we have our frequency. So our frequency is 0.8 pi. So the period is equal to 0.8 pi. And I know that the frequency is going to be equal to 2 pi divided by the period. So I'm just going to use that formula now. So the period of the frequency, actually this formula wouldn't be useful. It's the other formula that would be useful. The period is equal to 2 pi over b, because I do know what the frequency is. This is incorrect. This statement should actually say that the frequency is 0.8 pi. So let's find the period. So the period is going to be equal to 2 pi divided by 0.8 pi. So pi divided by pi cancels out. Now I have 2 divided by 0.8. So I'm just going to go to my calculator app and do that real quick. How do I get out of this? Okay, so I do 2 divided by 0.8, and I get 2.5. So that means that the period is 2.5 seconds. So the period is 2.5 seconds, which is one of our requirements for this problem. So we know what that means. What does that mean in the context of this problem? Well, that's how long it takes the cosine curve to complete its curve. In other words, that's how long it takes the nail to go from the floor all the way around and back to the floor. So in other words, it's how long it takes for the nail to rotate around one entire rotation, 2.5 seconds. So at 0 seconds, it should be on the floor, and at 2.5 seconds, it'll come back to the floor as well. 2.5 seconds. Now halfway through, I'm just going to count the number of boxes I have here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 of them. So at the 10 mark, we should reach the maximum value of 26. And at the 5 mark, we should reach 13. And at the 15 mark, we should come back to 13. So this is our graph. So that's one complete cosine curve. Starting at 0, the tire will rotate as the nail will approach the top of the wheel, and then after 1.25 seconds, the nail will be at the top of the tire. It will continue to rotate down to the bottom as we get to a full 2.5 seconds. And its maximum height will occur at 26. So, does the height of the nail ever reach 30 inches above the ground? I'm going to leave this open for you guys to answer on your own, as well as the remaining questions on this page.